Hi friends, let's discuss something about what is the difference between mass and weight. See, in general common sense, both of them are deemed to be the same meaning, but as we go deep in the physics, it has a lot difference, lot of difference. Yeah, first coming, what's mass? It can be defined. It can be addressed in two ways. What's the first way? First way, let me speak in a general sense. It's the stuff present in the any material. What is the stuff? Matter. What is the matter present in any object is its mass. What is matter? It's molecules present in the any object. That's the mass of the object. This mass never gonna change wherever you go. This remains constant. It's basically like the stuff. The matter contained, the atoms contained in the object. That was the mass stands for. It's like in general sense, and most of the physics uses this as a mass. And the second thing which can be addressed as mass is that how strong a force responds. This is also can be how strong a force responds is also termed as mass. This is well understood in the Newton's second law. When we come to Newton's second law, this we will be discussing in detail. So that's what it stands for. As we know, as mass increases, acceleration decreases, and as acceleration increases, mass decreases. Mass decreases, acceleration increases. That's what. How force responds is also defined as mass. That was the whole story about mass. Now coming to weight. What is the weight? In general sense, both of them, mass and weight are seen to be similar, but they are not. In physics, everything goes like there are some identical, but not what you think. Technically, weight is force of gravity on the object. Force of gravity on the object. Gravity on the object. See, let's consider the same thing. Let me give you an example. See, let's consider an object, a person whose mass is 70 kilograms. So, whose mass is 70 kilograms. Then, what's the weight? Weight is g of m1 into m2 by r square. See, m1 is the mass of earth. M2 is the mass of object. R is the distance between center of the object, to the surface of the earth. G is a constant. So this what, if we substitute everything in this, we will get the weight of an object in earth. It's not only in earth. When you substitute the mass of with an earth, you get a weight in earth. When you substitute m1 with mass of moon, you get weight in the moon. It's like it differs. But the mass you gonna what's the m1 value, that's the weight in that particular situation. So here mass is 70 kilograms. Weight in earth, let's take in earth. In earth, G is equal to, as we all know, G into m1 by r square. This is 9.8. It is stable. In earth, we know that G stands for the gravitation in earth is G into m1 by r square. This is 9.8, meter per second square. Do you get it? As it is this value of earth is 9.8 meter per second square. So we're gonna multiply 9.8 meter per second square with m2. That is the mass of the object. What is the mass of the object? Let's take we have taken 70. That's nice. Yeah, 70 kilograms. Then what is the value? It is 70 into 9.8, then it comes to roughly 686. Yeah, 686. What is this? Kg into meter per second square. What is this kg into meter per second square? This is Newton. We all know that Newton stands for kg into meter per second square. So for an object of mass 70 kilogram, the weight is 686 Newton. Yeah, I'm right. Yeah, Newton stands for kg into meter per second square. This is what Newton stands for. When the same object, when we multiply m1 in the above formula with the mass of a moon, we get the weight of the object in moon. Here, weight in moon can also be obtained as the gravitation of the moon is 1/6 of the gravitation of the earth. That's, I mean to say, it's 1/6 of 9.8 meter per second square. Then it comes roughly around 1.63333. It goes on. When you multiply this with 70, you're gonna get approximately by like 114.3333. So I think you have got the difference between mass and weight. So mass is just a tough matter, I mean to say molecules present in the body. Weight is just a gravitational force. It depends on the what force, I mean to say what object you are gravitation towards, force of gravitation. Yeah. So when the 70 kilogram of mass weighs approximately 686 Newton in earth, the same mass of 70 kilogram weighs approximately 114.333 Newton in moon. So mass remains constant. The only thing that changes is weight. Weight is a force of gravitation. I mean to say force of gravity on an object. That stands for weight. So that's it, friend. Hit like, do share and subscribe.